Hello, my name is Ben Hundley with Octane. I'm a cloud engineer, and today I'm going to be talking about taking a bite out of your cloud storage costs. Primarily in the cloud, we have two types of storage. There's block storage and object storage. Today I'm going to be talking primarily about block storage. Block refers really to two things. First, the underlying hard drives, hard disks that are used to power the storage. The block refers to how files are written in chunks or blocks. The common use for the term block storage now really refers to storage area networks or SANs in the cloud. And a common example of that would be Amazon's EBS or Elastic Block Store. So some common use cases for block devices would be databases, distributed file systems, shared file systems, boot disks and images, so the files that allow your server to come up, and then some ephemeral data, stuff like sessions and cache, etc. Starting with the lowest hanging fruit, removing orphan volumes. What happens in the process of development is you have your little cluster here, early versions of your application. It's running a pod, a container. It has a persistent volume in Kubernetes, and that results in an actual physical disk out there. That cluster is deleted, new cluster is created, new cluster is deleted, another cluster places it, and then you have two orphan disks. And those really add up to the point where every month or so you check your volumes page and you see hundreds of blue icons in AWS, just available disks not being used. I saw an article that said there's an estimated 3 billion spent a year on unattached volumes, so it's probably fairly low-hanging fruit. So you can automate the cleanup. AWS even has a good article on that using Lambda, and you have to enable CloudTrail to be able to know when a disk was detached, though. So that is the one thing. And to prevent this, for example, for a non-production environment, set your default storage class or your PVCs to have delete for the reclaim policy. The second thing is reducing snapshot costs. So this is here just representing what would be a mission critical application on a cluster. And so you start taking snapshots. Typically you'll have every hour, take another one, and eventually because of the cost here, you want to switch to a lower fidelity or like less granular snapshots. EBS snapshots on Amazon, they are incremental. So technically, if you had a purely maybe time series database with no updates, you may not be able to save a lot of cost by deleting snapshots here and there. Data sets that are heavily updated, though, they probably will end up spending a lot of money just for frequent snapshots. And so eventually the real way to start to save money here, the older snapshots, ones you don't expect to really ever act on, ever access or restore from, you can offload those to cheaper storage like S3, object storage, and then you can do the same type of retention policy definition over there where you have less granular intervals for the bigger time periods. AWS has a data lifecycle manager, so you can set up some of that stuff for the snapshot windows, even though it is pretty limited. So you have to set up quite a few of those lifecycle managers to get those rolling windows. Anything that's infrequently accessed or unlikely to be accessed, you can save a lot moving it to S3. Use available ephemeral storage. So it's free real estate if you have it is the thing, right? So Amazon, a lot of the instances are EBS only. I even think EKS locks you to using the EBS only instances, but in cases where you're bare metal or you're running your own cluster on Amazon, I know a lot of people I've worked with, they've, as a company, had big pools of like 3-year reserved instances, and they'll all have multiple local disks. And you can definitely get a little bit better performance, but there's definitely some caveats. If you lose a node, the data's lost, and you don't have that nice container attached storage effect where a pod can like move freely node to node and the disk can reattach. So you can mitigate that problem with replication. It obviously, the trade-off there is that it's going to cost more in compute, but if you have that space available, it's theoretically cheaper than adding EBS volumes that you don't need. It's definitely a trade-off to consider, and if you have a bare metal setup, something like OpenEBS that deals with this type of replication and local PV provisioning, that's a good package to include in your cluster. Storage tiering, this is definitely a more advanced idea. Recently, this is something that we're using Timescale DB on a project, and it's built on top of Postgres. And Postgres has table spaces that can map to devices on the back end, and it allows you the flexibility of using cold hard drives, cheaper devices, mapping those to cheaper clients. It could be older data. And that type of tiering is something you're usually going to have to handle dependent on the application. And just listing some other considerations. A lot of times people will just allocate one huge disk anticipating some scale, like terabyte EBS volume. You could theoretically just gradually scale up vertically with smaller disks if you're employing something like RAID with striping or ZFS, or there's even application-based striping. Elasticsearch, for example, you can just add disks and give it to the config and it will do the striping for you. Compression, another thing you could get with ZFS through the file system, but it's also something that's application-based like Timescale, and I think Elasticsearch have their own native compression. This is just a link to if you're using ZFS with the ephemeral disks like I was talking about. This is a really good provisioner from OpenEBS. And this last point here, I used to work at a startup and I managed hundreds of big Elasticsearch clusters. People would hear, production setup, you need 2 replicas. But if it's a big data set that can tolerate an hour or 2 hours or even a whole day to recover as long as the data comes back, there's really no point in spending all that money on the CPU and RAM to keep that replica live, when you could instead just invest a smaller amount of money in consistent backups and a process to recover. And then finally, so all these optimizations can be expensive in and of themselves. So it's worth consideration. You might be able to reduce your total cost of ownership with some of the managed services, such as like Amazon RDS or just database management services, just because they offer pay-as-you-go pay-per-gigabyte models that probably do offset, even though they're 2-3 times the base gigabyte cost of disks. It reduces the inefficiencies and the maintenance you're having to spend money on. And that is it. Thank you very much.